and fall back down again, they emit light of particular colours. And so the fact that atoms, when you heat them up, only emit light of very specific colours was one of the key drivers that led to the development of the quantum theory, the theory of the structure of atoms. I just wanted to show this picture because this is remarkable. This is actually a picture of the spectrum of the sun. And now this is a picture of atoms in the sun's atmosphere absorbing light. And again, they only absorb light of particular colours when electrons jump up and fall down, jump up and fall down. But look at the number of black lines in that spectrum. And the element helium was discovered just by staring at the light from the sun, because some of those black lines were found that corresponded to no known element. And that's why helium is called helium. It's called helios. Helios from the sun. Now, that sounds esoteric, and indeed it was an esoteric pursuit, but the quantum theory quickly led to an understanding of the behaviours of electrons in materials, like silicon, for example. The way that silicon behaves, the fact that you can build transistors, is a purely quantum phenomena. So without that curiosity-driven understanding of the structure of atoms, which led to this rather esoteric theory, quantum mechanics, then we wouldn't have transistors, we wouldn't have silicon chips, we wouldn't have pretty much the basis of our modern economy. But there's one more, I think, wonderful twist to that tale. In The Wonders of the Solar System, we kept emphasising the laws of physics are universal. It's one of the most incredible things about the physics and the understanding of nature that you get on Earth, is you can transport it, not only to the planets, but to the most distant stars and galaxies. And one of the astonishing predictions of quantum mechanics, just by looking at the structure of atoms, the same theory that describes transistors, is that there can be no stars in the universe that have reached the end of their life that are bigger than, quite specifically, 1.4 times the mass of the sun. That's a limit imposed on the mass of stars. You could work it out on a piece of paper in a laboratory, get a telescope, swing it to the sky, and you find that there are no dead stars bigger than 1.4 times the mass of the sun. That's quite an incredible prediction. What happens when you have a star that's right on the edge of that mass? Well, this is a picture of it. This is a picture of a galaxy, a common or garden galaxy with, 100 billion stars like our sun in it. It's just one of billions of galaxies in the universe. There are a billion stars in the galactic core, which is why it's shining out so brightly. This is about 50 million light years away, so one of our neighbouring galaxies. But that bright star there is actually one of the stars in the galaxy. Right. So that star is also 50 million light years away. It's part of that galaxy, and it's shining as brightly as the centre of the galaxy with a billion suns in it. That's a type 1a supernova explosion. Now that's an incredible phenomena because it's a star that sits there. It's called a carbon-oxygen dwarf. It sits there about, let's say, 1.3 times the mass of the sun, and it has a binary companion that goes around it. So a big star, a big ball of gas, and what it does is it sucks gas off its companion star until it gets to this limit called the Chandrasekhar limit, and then it explodes, and it shines as brightly as a billion suns for about 2 weeks, and releases not only energy but a huge amount of chemical elements into the universe. In fact, that one is a carbon-oxygen dwarf. Now, there was no carbon and oxygen in the universe at the Big Bang, and there was no carbon and oxygen in the universe throughout the first generation of stars. It was made in stars like that, locked away, and then returned to the universe in explosions like that in order to recondense into planets, stars, new solar systems, and indeed, people like us. I think that's a remarkable demonstration of the power and beauty and universality of the laws of physics, because we understand that process, because we understand the structure of atoms here on Earth. This is a beautiful quote that I found. We're talking about serendipity there, from Alexander Fleming. When I woke up just after dawn on September 28, 1928, I certainly didn't plan to revolutionise all medicine by discovering the world's first antibiotic. Now, the explorers of the world of the atom did not intend to invent the transistor, and they certainly didn't intend to described the mechanics of supernova explosions, which eventually told us where the building blocks of life were synthesized in the universe. So I think science can be, the serendipity is important, it can be beautiful, it can reveal quite astonishing things. It can also, I think, finally reveal the most profound ideas to us about our place in the universe and really the value of our home planet. This is a spectacular picture of our home planet. Now, it doesn't look like our home planet. It looks like Saturn, because, of course, it is. It was taken by the Cassini space probe. But it's a famous picture not because of the beauty and majesty of Saturn's rings, but actually because of a tiny, faint blob just hanging underneath one of the rings. And if I blow it up there, you see it. It looks like a moon, but in fact, it's a picture of Earth. It was a picture of Earth captured in that frame of Saturn. That's our planet from 750 million miles away. I think the Earth has got a strange property that the further away you get from it, the more beautiful it seems. But that is not the most distant or most famous picture of our planet. It was taken by this thing, which is called the Voyager spacecraft. And that's a picture of me in front of it for scale. Voyager is a tiny machine. It's currently 10 billion miles away from Earth, transmitting with that dish with a power of 20 watts, and we're still in contact with it. But it visited Jupiter, Saturn, Uranus, and Neptune. And after it had visited all 4 of those planets, Carl Sagan, who's one of my great heroes, had the wonderful idea of turning Voyager around and taking a picture of every planet it had visited. And it took this picture of Earth. Now, it's very hard to see the Earth there. It's called a pale blue dot picture, but Earth is suspended in that red shaft of light. That's Earth from 4 billion miles away. And I'd like to read you what Sagan wrote about it, just to finish, because I cannot say words as beautiful as this to describe what he saw in that picture that he had taken. He said, "Consider again that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you've ever heard of, every human being who ever was, lived out their lives. The aggregates of joy and suffering, thousands of confident religions, ideologies and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam." It's been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. Beautiful words about the power of science and exploration. The argument has always been made, and it will always be made, that we know enough about the universe. You could have made it in the 1920s, you wouldn't have had penicillin. You could have made it in the 1890s, you wouldn't have had the transistor. And it's made today, in these difficult economic times. Surely we know enough. We don't need to discover anything else about our universe. Let me leave the last words to someone who's rapidly becoming a hero of mine, Humphrey Davy, who did his science at the turn of the 19th century. He was clearly under assault all the time. We know enough at the turn of the 19th century. Just exploit it, just build things. He said this, he said, "Nothing is more fatal to the progress of the human mind than to presume that our views of science are ultimate, that our triumphs are complete, that there are no mysteries in nature, and that there are no new worlds to conquer." Thank you.